Okay, and we have updated the grammar slightly, so the program looks nicer now. So we have namespace university, the colon is here. This is our DSL program, and this is the, oh, this is actually some old code, interesting. Sorry. Here we go. This is the code we want to generate. So let's go look at our generator. And again, we have the doGenerate method. This is a framework, the code generation framework. This method is called whenever you save your DSL program in the runtime Eclipse. And we have the resource, which contains all of the objects in our metamodel instance for the given program, the file system access, which is convenient for generating files, so for helper thing, and then the context that we can use for a bunch of other stuff. And in this case, we want to find, again, we actually did this in the last generator as well, we want to find the entity objects and generate classes for those. And I'm actually just going to go and look at the old generator code and see if for the entity from last time, and just reuse part of that. I'll walk you through it quickly, but I think we can reuse the same thing. So I think this is the entity here. We have an entity language generator here. So let's just copy paste this thing here. And this will probably have, no, it actually doesn't. Okay. So whereas in Eclipse, sometimes if you're doing Java, it will, if you copy paste between projects, it will cleverly try and figure out the imports from the other projects for you, which is a disaster in a case like this. It doesn't actually do it here. So let's see. So resource.all contents, this is all of the objects. We filter to give us those that are of the type entity, and entity is actually also the name we gave it here. So here we go look in our entity, and then we say for each of these entities, do generate entity file. And generate entity file is the one down here, which generates a file with the name Java. And then, well, that's the basic stuff here. We need to introduce, this will generate a single, we'll have import, public class, an entity might extend something. For attribute, here, we import that. And relation. So attribute and relation are the two things that we have. Okay. There's something slightly broken here with the is many, but I don't think we actually, we only have the, so in the previous entity example, we could have relations that were one-to-one or one-to-many or many-to-many or whatever. In our entity++, if there's a relation, it's always many. No, actually, I put the multiplicity there. Okay, so that's going to need some work. Yeah, let's just leave it like this. If we look at the code that we want to generate, there's actually, this should be package university here at the top.
Namespace.
which we get from the namespace. But this is Java code, so package university, because we said namespace university. So we need to put that in there. And actually every entity that we generate is going to need the same namespace. And if we go look at our grammar here, then the thing is actually that this root element, the entity plus plus language or whatever we called it, has both the name of the namespace and also our list of external functions. And if we're going to generate the interface that defines, or the abstract class, as we ended up agreeing, that defines which things to put here, we are going to need this as well. So let's go, this is the point where we have our resource. So let's find, and now we want our EPL. So resource.allContents.filter type of EPL. And I think this is an iterator that we can call next on. So this is, so we know for sure that unless there's something horribly wrong with xtext, the resource.allContents.filter type of EPL is going to give us exactly one argument. So I'm not going to do an if there wasn't anything here, then throw an error. I could have put in an insertion or whatever, but there is going to be one unless there's something really broken in our whole setup. So there's going to be exactly one EPL, and when I call .next on our iterator, we get that one instance. So I can pass this. Sorry. And then here, entity E, EPL. Okay. Now the name here of the file we want to generate is then the EPL has a name. So we do EPL.name, which is going to be and then a slash. So if it's university, then university slash whatever.java. And the file system access friendly helper class actually does the right thing here. It knows that slash means a directory, not a slash in the name, which would be slightly evil. We also need to generate the interface, but that's we're probably going to do that elsewhere. Question?
If we did this on a Windows machine, wouldn't the slash be the other way around?
No, because it knows what I mean when I write slash.
Okay.
Because only stupid people use backslash to separate directory names. Well, or people who happen to use Windows or whatever. But just backslash has a different meaning often when we program, so that's why it's kind of inconvenient to be using it here. Slash is used as a generic separator for path names.
Okay.
And that works, it does the right thing on different platforms. Meaning, on Windows it knows to use the right thing.
Great.
I guess Java still insists that you... What does Java and C# do? Do you have to use backslash on Windows still, or does it know how that when you write slash you actually meant directory separator?
I think you can use force.
I think you can use it, right? Yeah. So another thing we need to put in here is our package declaration. So we need to know the name down here. So let's just put this, and then, so this is when we have EPL, like this. Package, EPL.name. And this is Java, so we need a semicolon. Okay. We need a constructor. So let's go look in our example. We want the constructor to look something like this. Now I'm just going to grab things from my code and put them inside the generator, because that might be a convenient way to start. So we want a constructor that looks something like this. Wait, sorry, wrong place. get rid of this here, because we want the constructor to be, so here I'm actually generating code that has a field and then getter and setter. So that doesn't completely respect the Java convention, but I think that's close enough here. We could also generate all the fields first and all the getters and all the setters and the constructor in the right place, but it means our code generator becomes slightly more complicated. But it should be easy for you to see how to do that. I just need to split things up a bit more. So my code is now going to be public class person, or public class student extends person, and then we want the constructor here. So of course, instead of person here, it should be the entity.name. And now I want something here for each member that is an attribute or a relation. This is actually slightly complicated, right? So for each attribute, I want the name of the thing here. For each relation, it should be a collection of whatever it is that I'm giving it, or a list. Oh, should we use collections or list? Any preferences? What should the relation be represented as? A list or a collection? Who votes for list? Good old list. 4 people. Who votes for collection? The more generic choice. 2 people. We'll go with list. Okay. So basically this should be, so I want to say 4, and now I want for each entity.member, which is either a relation or an attribute, generate the thing that represents a parameter. So this is slightly complicated, so I'm going to use a helper method, which is of course, so as a general rule of thumb, you always want to keep your generators, the templates, as simple as possible. Let's call these our data. So this is a helper method that I'll write in a second. So each of the ones that are data, so data is either an attribute or relation, generate a parameter in the constructor, like we had it here. Okay, and I need an n for, and it should be members.data, and this should be an extension method. Def, this should be, let's just leave that. So this is going to be an e-list member as well. Okay, so for each of those members that are data members, so the attribute or relation, do d.generate parameter. To generate this as a parameter. And again, I'm going to generate parameter. So generate parameter, this is going to be a dispatch. Now remember the dispatcher, this is the multi-dispatching, the fancy feature in xtend that lets you dispatch based on the type at runtime. And so if we say it's an attribute, then generate this. And if it's a relation, generate this code. Okay. So now I have public name of the class, parentheses, for each of the data members, I call the generate parameter. And then of course I also need something in here. There is one thing missing now in this code here. Something which is slightly annoying. Now if you look at this, there's a comma. Right? I need a comma in there. But the annoying thing about commas in a language like Java is that you can't just put a comma anywhere you want. You can't have a comma at the end. So you're only allowed to have commas in between things. You can't just put a comma after everything. That would be nice. That would make it much easier for code generation. But it's a separator, so you can only use it to separate things. You can't use it just like a semicolon after whenever you want to, basically. Well, semicolon isn't precisely like that, but so that's annoying. And actually, it's so annoying that they came up with a separator declaration like this. So if you write separator, it means, oh, this for loop which is generating code for me. It's going to generate a bunch of stuff between each stuff, but not at the end and not before it. Put the separator, which is very nice because writing the code manually that puts the comma exactly in the right place is annoying. So this is a nice feature of the xtend generator language. And then inside here, we want something like this for, and we're just going to do that on a for loop again. So then we're going to do for the entity.members.data. So these are the ones we have. And then it's going to be this dot underscore d dot name. So now I have a problem here. So it doesn't, I can't say d dot name because attributes have an a name and relations have an r name. So I use this to explicitly indicate that it wasn't actually the same kind of name as we have in other places, but that's becoming inconvenient now. On the other hand, so we could change this to have it be, we could put like name and name here, but if you look, now we try and think ahead about what our meta model is going to be. If I change this to be name and name, then attributes and relations will have a name. But require doesn't have a name. So members will not have a name. So we have two options here. We could introduce into our grammar something we call a data member, which is either an attribute or relation, and then have the names be like this. Because then our meta model would have that members are either data members or requires, and data members are attributes or relations, and attributes and relations both have a name, so data members will have a name as well. That's how the meta model derivation works. If all subclasses have something, all subrules, then the super rule, the superclass gets it as well. Let's not do that because this adds some extra complexity here, and we're just going to fix this in the code generator. So I'm going to have a helper method here called data member name. Okay, data member name can take an attribute a and then a.a name. And then we have for a relation, it's r dot name. If this was ever called on something not, so if this was ever called on a require, that would be legal according to the types, you would get a runtime exception. This would be like trying to cast something to the run type. So this would give you an exception at runtime. I know looking at the program right now that that's never going to happen because I'm only going to call this on things that are attributes or relations, but the type system doesn't know that. And I could later on do something in a program where it breaks. And xtend doesn't require you to cover all type cases here. So to be sure, I would have to put require here as well, and then throw an error if it was a require. But that's just noise somehow, because if it's a require, it doesn't make sense, and that's what's going to happen anyway here. So let's call it underscore d.data member name. Okay, so that's going to be all of these. Info. Okay, somehow a constructor is actually surprisingly complicated to generate compared to some of the other things, because it needs to have a whole bunch of parameters, and there's more code in it somehow compared to the simple getters and setters we've been doing so far. Okay, so now my constructor is almost ready. I just need to complete these methods here. So, given a list of members, we want to create a new list that only has those that are attribute or relation. So let's see if we can do list.filter. Let's see. I have been using lambdas in too many different languages here. Let's see, is it like this? Let's see, type of bugger. Sorry. Now's actually a good time for a break. So let's and my screen recorder is, well, I'm not recording this anyway, apparently. It's annoying. There seems to be something. So my screen recorder program has worked reliably for me for many years, but for some reason right now it seems to be sensitive to when I'm using it with the projector here, and that's sort of surprising.
Or did you update
it?
Did you update it?
Well, at first it didn't work, which is why I lost the first recording. And then I thought, okay, so now is maybe the time to update. So I updated, and I lost the recording again now. So neither the old version nor the new version worked. In any case, it's still a good time for a break. Okay, let's pick up again. So there's some things in the xtend language that I find comes very naturally, and then there's some things that, because they rename some operators in Java, and the way you refer to types and things that I don't use so often, that I sometimes have to look up when it's been a while. So that was one such case. So we wanted to define this method data that takes a list of members and returns those members that are attribute or relation. There's a helper extension method called filter that you give a lambda with a predicate, and the predicate here is that it should be, the class should be attribute or relation. Actually, I just want to try something here. Yeah, you can actually, so xtend also has, so in a lambda, or in any case it has this keyword it that you can look up. It's almost slightly too clever, but I think they felt really good about using it. it's if you don't say what is the parameter, then you have a default parameter called it that you can use here. So let's use that. Now we just need to define generate parameter for attribute and relation. So an attribute has a name and a type. So, and we need to put attribute.type and let's just see, and then attribute.name, name. For relations, we decided to use list. So this is going to be list of the type, and then the name. Oh, this is the relation, sorry. Yeah?
In your data method, are you filtering the list? Is that passed by reference? Or how do we know that the list is there a new list returned?
So that it says in the Java doc, this gives us a view on the list.
Okay.
So it doesn't make copies of the elements, but it selects elements from the list and returns us an iterator that selects precisely those elements from the list.
Okay. Cool.
If we make modifications to the list, we might get unexpected results,
Yeah.
although it is kind of defined what the results are here. Usually we don't modify the meta model after it has been constructed, so we're actually fine here. We might, in other cases, have needed to be more careful. So, there's actually a problem with the way we define attributes and relations, but I'm going to leave that because that problem is going to be very obvious, these two methods here, and actually it's a problem that we sort of inherited from by copy-pasting the code, so it's a copy-paste problem, but we're going to see that when we run the generator. Let's just look at the generate member here. It's always going to, we had the multiplicity, but it's always going to be a list in any case. So here we always represent relations as lists, but the multiplicity is then a constraint on how many members are you allowed to have in the list. So it will be a constraint on the list length. So if the multiplicity is 2 to 5, then when we call validate, we check whether the length of the list is between 2 and 5. So we're always going to have the list version of it. So move this, and since it's a list rather than collections, it's going to be like this. So this is a candidate for our generator. So let's try it out. Run as, keeps application. Of course, this doesn't include everything. Just like with ordinary programs, when you write them, it can be a good idea to test your program a few times before you've written the whole program. You sometimes do that, right? Good. Same thing for generator. So we force it to save, and if errors happened during the generator, that can happen. We could get a null pointer exception or some other error. Then there would be a pop-up saying, oh, there's an error, and we could then go look. Oh, there might be an error here. Let's see. Oh, that's something else. Okay. So entity plus language test. This is kind of surprising. So I expected there to be a source gen here. Let's go look. Um, okay. Oh, sorry. That was the Java file I modified and saved again. That did not trigger the generator to do something. Try again. Okay. Oh, there's actually a problem here in the... Ah, okay. So now we did get an error here. So let's go look. So this might be this is slightly different from the error I was expecting. Let's see. And to find the code that looks like our code here. Here we go. Unhandled parameter, which is the one we had. And this is inside generate member. Ah! We have requires as well, of course. Alright, so this is saying when you, in the call of generate member, there was an unhandled parameter type. Why is there an unhandled parameter type there? So this is an error in the dispatcher. When you have a dispatch method, the one that selects between different types, and there's a type that it met that you didn't actually include there. And if we look here, we have generate entity that for each member calls generate member, and we have generate member for attribute and relation, but not for require. So of course, when we get to a require member, we get an error because there's no method defined for it. So let's just require. Am I in the wrong file? Ah. Thank you. Let's get rid of this. Yep. Entity plus language here and entity plus. Okay. So try again. Generate member and generate member. Now, if we think about it, the requires actually, since they become part of the validate method, I probably don't want to generate code every time I see a require. So, I probably would be fine with an empty string for now. Because I expect that my requires will all be part of a single validate method. So I could put the requires anywhere inside my entity declaration, but I want to put them all in one place. Whereas the generate method here deal with the generating output for attributes and relations. Okay, so let's try again. Run as Eclipse application. Okay, so we try this again. Now this error is actually from something else that I should just get rid of. So now we have the source gen university package that we wanted, and we have classes in here. Okay, let's make the source gen be a source Java folder. because this makes it a bit more aggressive in how it checks things. So it turns out that there were actually some problems there, a whole bunch of problems. So let's see. Now, does this look like normal Java code? Well, some parts of it does. I mean, we have package, class, person, public person. So I think my nice method that was supposed to select the data members didn't work because it must have returned an empty list here. So we need to go look at that. That's of course the I thought I remembered how to do that, but apparently not. And then there's this here. What was this supposed to be? Yeah?
It was just supposed to be a private integer field.
Yeah, so it does have private. Yeah?
Isn't it a type?
Yeah. It's actually, and then add something, it's actually the default toString being called on an eCore objects, which is the objects that our meta model is made of. So it is because the code that I copy pasted before types were strings. So when I said something.type, I got a string, which is what I wanted. Types are no longer strings. Types are represented using objects. This is actually something we wrote about. So let's see here. See, when we go to the too many here. Types are objects, either int type, string type, or decimal type. So when we just say something.type, we get the object, and then it calls toString on it and inserts it nicely and friendlily into the generated code, which is absolutely useless, of course. So we need to tell it how to convert a type into, and that's of course the point here. We wanted to use objects also as a way of saying, and this is abstracted. We have also something called a decimal, which should probably be a double here. So we need to do that for our types. So we probably want here for types, we probably want that let's call it JName, because it's the Java name of this type. The JName, everywhere we use .type, we should say .JName. And I'm just going to, I wonder if the thing I cleverly thought would work with. Ah! Okay, I know what the problem is. So here I'm saying, in my clever filtering, I think at least I know one, you know how debugging is, right? You need to find one problem, then find the next one. So first problem, attribute is an interface. And I'm saying here, if the class of my object is precisely the class of that interface, then put it in the list. But of course, there's never going to be an object whose type is precisely an interface, because you can't make instances of interfaces. It might be a subclass of that interface. So does anyone remember the method in Java for checking whether you can? Is it just in stuff like this? Oh, maybe like this. Is there a method like this? I think. Yeah, but the thing is, that's the thing that bothers me here. So xtend doesn't call it instance of. But Java classes.
But isn't it without the dot?
Yeah, but the instance of is an operator. But xtend doesn't have that operator, which is what's bothering me now. So I'm desperately looking through the Java doc here. So if I write instance of, it's not legal xtend syntax. And there's some other. Oh, this is the object. Just a second. So here, should be here. So this is, I have a class object, and I'm sort of cheating here because there is instance, yeah. I think that's what we want here. I'm sure there's a better way of doing this. In xtend, but I just couldn't find it in the xtend documentation right now. It's the thing about remembering to read the documentation. It's been, well, I do that sometimes, but anyway, I think there's a chance this might work. We need to define the JName method here. So JName of a type. So types might be, let's go look. A type might be an int type, a string type, or a decimal type. So int type. This is the int, like this. And then it might be a string type. That should be string. And now look how, as I add methods here, before it was illegal because I said int type and this was not an int type, but now I have int type and string type, and the common super type of those is the type class. And so all of a sudden this becomes legal because I'm now defining the different things that I can dispatch to, and this should be a double. Oh, this is actually, so for relation is actually the name of the relation, because that wasn't our new type class. If it's an attribute, then we need the JName. Okay. So now we fixed, I hope we fixed my clever filter function here, which is feeling slightly less clever because it was a sort of slightly painful to write. And we definitely did something about the name of the types being inserted into the code. Now hopefully when you see something similar being inserted into your generated code, because that is probably going to happen, you will remember that, oh, I needed to do something to convert the object into an appropriate string representation. Oh, this actually fixed it. Let's go look at the code. Okay, so package university. My filter function still doesn't work. But now I have the different getters and setters. I'm still using underscores in my DSL program, so I get slightly nice, non-nice names, but that's okay. Okay, let's just do this the stupid way. Let's list of member result. Actually, we don't need the declaration result. equals R. Okay. For xtend list. Here we go. If extra class then result dot add of x this, okay, and then result. So in xtend you don't have to use the return. Whatever you put as the last thing is returned as the result of the method as a whole. Let's try this. And now there's a risk that it still doesn't work, of course, because the xtend has a slightly different way of doing the type checks that we usually do in Java. And that's the thing that's bothering me now. So it just worked. Okay, still doesn't work. It's annoying. Now we can try something else. I can show you something else actually. So here's the xtend documentation. And it can be a good idea to take a look through it. So one thing that xtend has is a sort of a switch on steroids where they try to somehow generalize it. And one thing it does is, for example, allow you to do a switch that looks at the type of something. So if we do a switch x here, and then do attribute, so see here, then sort add of x and relation, and otherwise don't do anything. Okay. Now this is the way you're supposed, or one way that xtend suggests you can do type checks.
Is there no cases in that switch?
It's
It's like case attribute maybe.
You don't, if it's if you're just checking on the type, you don't have to write case.
Okay.
If you write case, then you can write a Boolean expression afterwards.
Yeah, okay.
And in that Boolean expression, in this case, here you have switch x, and it's a if x is of type string, case, something where you can access things that only are valid if x is a string. So, I mean, I think there's something interesting. It is actually an interesting observation in terms of language design. Because some things in xtend I find are easy to remember, like the dispatch methods, they come naturally, the generator syntax, and some things are a bit, somehow the syntax, the switch, for example, if I haven't used it for a while, I sometimes need to look it up. And to me, that's sort of a sign that maybe there's something in the language design that didn't get completely right there. Okay, now something happened at least. Okay. Now this worked. So the problem was with my, I don't know if it was the filter or my lambda with or is instance of, or whatever it was I was calling. Now we're getting the right parameters here. We're getting some illegal code here. And I'm missing the underscore in the parameters and semicolons. Yes, good point. So let's go and do that. So in my constructor, I have generate parameter. Generate parameter says the type, and then now underscore name. Okay, so that was for the parameter. To get that, so now it's going to be underscore age here. And then we need the semicolons, as someone correctly pointed out. And here's assignment like this. Okay. And again, we have to slightly, to meet, I mean, again, getting the constructor right is something that compared to sort of, I mean, it's not, it's like the simplest code ever, but it actually interacts with many parts of the model, which means that we have many things we need to touch. Okay. So now we have correct things everywhere here. And now we finally can do the validate method. And so for the validate, we could put that at the end here. And I could, well, let's just public boolean validate this. And my validator is going to insert a test here for each member that is a require. So for each require, I'm going to do a test here. Let's see, do I still have the manual written code here? Yeah. So my validator takes for each require, it says if not whatever the require was, return false, and then at the end return true. So I need to return true at the end here, and then I need a for loop for m in entity.members m.generate require n4. Okay, and then we want to generate require method. Just put it at the end here. So a generate require with an attribute should just be an empty string. A generate require with a relation should also be an empty string. And now a generate require with a require. That one needs to do something. So for require, we want to do if not whatever the body of the require was, return false. So let's do that if not require.generate condition return false semicolon. We want to generate require. So now let's go look at the require here. Oops, sorry, now let's go look at the xtext. So a require is either something that has a disjunction or something that has a require external. So I actually didn't use types to distinguish them here. So I can't use the dispatch. So I have to go look at, is it one or the other? And if it's, wait a second. Or do I? No, actually, so if it's a, my require is either going to be a disjunction or require external. So actually what I want to I require external. Oop, wrong. Again, I have to, let me just check that this is in fact, yeah, okay, good. And this junction. Okay, now just to, the thing is, the require here has two possibilities, disjunction or require external. There's also a non-terminal here, but xtext just ignores that from the point of view of the meta model. So from the point of view of how the meta model is put together, these are just going to be subclasses of require. And so I can dispatch on whether it's a require external or a disjunction. Or a, let's just see here, or actually it might be a conjunction or logic term. It could also be a conjunction, or it could be a logic term, or a comparison. Logic term. Isn't that what it's called? Let's see here. No, actually, so logic terms are either a comparison, which is a generic thing, or a disjunction. And a comparison, so it's a comparison we want. Comparison. Yeah. So, oh. So sometimes we have to be a little bit careful with the classes here. Interesting. I think it's that's actually surprising. The comparison expression that has a left. Okay. For some reason it is suggesting that I shouldn't use it, and I'm not sure why. So let's just try this out. So I'm just going to write external dot, just to try this out, require dot, and an external has a name of a function. This, and I'm just going to wait with the rest of the syntax here. Disjunction. So disjunction, that's something with a logical or between it. So this is going to be a require.left and or and a require.right. Now something when you generate code for expressions like this, you need to consider how many parentheses you want to put in there. You could be clever and put as few parentheses as possible to make the generated code as readable as possible. But there might be, depending on the precedence of operators in your target language, it might be convenient to have parentheses to enforce that it actually gets precisely the structure we want it to. So I'm going to do it here, which means we're going to generate too many parentheses, but we're just going to put them there to be on the safe side. And we want require.left.generate condition, quite right, dot generate condition. I think so, but see. And what happened now was that this became a recursive function here, and xtend doesn't automatically infer types for recursive functions. So let's put a char sequence here. So we're going to recursively call generate condition on everything here. If we get down to the comparison, this is our basic thing. So it has a left and a right that are terms, and so it has compare.left, compare.operator, and compare.right. Okay. So now I feel I'm a little bit unsure about the warning here. I will have to get back to you on why it's there, but I don't know if it's going to work at all. So now might be a good time to try it out.
There isn't a faster way than just, you know, restarting a whole new Eclipse and everything.
Sometimes it will automatically reload it, but I've experienced that it sometimes didn't, and I haven't quite found the system.
Okay.
So to be on the safe side, in particular when I'm doing it here, I don't want to risk any errors. So
Could be that there was some script that you could just fly with a file or something.
Yeah. Oh, interesting. Okay. Something bad seems to have happened here. So it's my generator only runs when I when I save the file. So I'm surprised that I couldn't open the editor here. Okay. Sorry about that. Uh, okay, so of course, if you have this kind of problem, I would just happily tell you to reinstall your xtext or something. But but that's my own problem. If we just take a quick look at what I did here, for the expressions, we have a recursive structure, and so a generator also becomes recursive. We have a generate condition here that goes through the structure. We insert lots of parentheses, because if we insert lots of parentheses, we're sure that whatever code we generate will also have the same meaning as what is expressed by the model. At the very bottom, I'm going to need to insert these. So this will need to be like generate term, generate operator, and generate term, because the terms might be variables and numbers, but I'm sure you can imagine that that's just going to be a dispatcher function on either variable or number here, which inserts the corresponding text. For the operators, we have a whole bunch of classes, so we're going to have a dispatcher over these that inserts the corresponding text. So basically a long list of dispatchers, and the dispatchers are organized according to names, what they do, and then the types they go dispatch over. And this is what our xtext generator typically ends up looking like. Now, one issue that we haven't actually really dealt with yet, but that is a complexity when generating classes here with constructors. Something that was a warning about in my Eclipse, but I dismissed quickly, is that a student did not have a correct call to the superclass constructor. Because, as some of you, I can show this code now, sorry, I have a copy of it in here. Okay. Well, I have person with age, first name, last name. Student then adds, I don't know, the student ID or whatever. But it must call the superclass constructor for all of the other fields. So in fact, a student class, when I generate that, should not just have the data members of this entity, it should also have all of the data members of all of the base entities, of the superclass entities. So when I create a student must also have a first name and a last name and an age, plus the ID. So the constructor is in fact even more complicated. So again, we have something that's relatively easy for people to write, but actually gets a little bit messy here. Other things are very easy to generate. I think maybe the runtime Eclipse refusing to do any more work was also a sign that it was a good time to stop, in the sense that you've seen enough here of how this works. I didn't show you how to generate the interface, but of course the way to generate the interface is to here have a call to something else here. So this would be we want to find the we don't want to call a generate entity file. We want to do a generate our external functions, which I have a wrong Eclipse, sorry. This class here. So this is, I have the method that generates entity files, and then I'm going to write a separate method that I will call just once that generates this class here. So this is a very easy template to make. This whole bunch here is going to be fixed. It's always going to be the same. I'm going to put in the right package name, and then I'm going to, for each, then I need to go through all entities and find all uses of requires that use an external function. Oh, actually that's not true. Let me back up. I need to go to, sorry, if you look at it here, I thankfully, because we have the declarations of the externals, I don't need to go look at all the uses. I just need to go look in my EPL for each of the externals here, generate a method in the abstract class. So that's going to be something like generate abstract class for EPL.name slash plus, so this is external functions Java, so that's the name here. And I then take EPL.externals. And I basically wanted to do this. And I probably, maybe I need to change this a little bit because it should actually be so this is the package name here. And so this just needs to be a for loop here. This will be for e in our list. And then I need to insert code here that generates public abstract Boolean, yes, and then e dot for function name. No, I'll probably call it name. Yeah, okay. Name. And then here we need something for each of the parameters. This is very similar to what we had in the constructor here. So for so let's just see here, an external has parameters which have a type. Params, what do I call it now? Okay. and we want a separator, comma. Then I want to do p dot generate parameter. Now we have one challenge here, which is that in my program I just write, actually you can see it here, but up above here there would be external legal name, string, comma string. So I don't have names of my parameters. But when I generate a Java prototype of a method, of an abstract method, I have to write names of the parameters. And the names must be unique. And I don't have the name information here. So I want to do something like the type. So this must be type.jname. And then I could call it x. But x is that's not going to be legal. So an easy fix is to have basically a field in the generator. So var parameter counter equals 0, and then do parameter counter plus plus. So this is going to, of course I can't run it now because I have this technical problem that I need to resolve, but this will generate, for example, for legal name, we're going to get an interface which is called, it's not going to be first name and last name, but it's going to be x0 and x1. That's code generation. It's more like normal programming actually, where the BNF actually, if you think about it, is very quick for me to write the BNF for this NC++ language. I needed to understand how to make the BNF for expressions, how to do the recursive specification, but once I got that, it was actually very quick to write. The generator, well, you need to learn how to make generators, but this is more like, it's more standard programming. The dispatchers make the code a bit cleaner. You can also use the switch that I showed you in xtend if you don't want to use the dispatcher. It's like a dispatcher insider function. It depends on what you prefer in terms of programming style. But it's basically just unfolding everything there is in the structure. In Fowler's book, he talks about template and transformer style code generation. So template is you have one big template and then you put stuff inside it. He also mentions transformer, which is for each piece of data, here's the corresponding text. Here we have a mix actually. So we have templates that are being generated for specific parts of the meta model. So this is sort of a hybrid between template and transformer as described in Fowler's book. I didn't go back and forth a lot here, but if you're in doubt about the code that you're generating, well then there's a slight, I mean, it takes, I don't know, 10 seconds to stop your Eclipse and start again, so, but I'm old enough that we sometimes had half-hour compile times for some of our programs, so it's just 10 seconds, so you'll get over it. Even so, it's, of course, it's a little bit annoying. The trick of inserting the code you want to generate inside the template, that helps you shape the way you write your generator. That works for many people. But it's also very much an iterative thing. So for the generated Java constructors, well, we hadn't thought about the call to the super constructor, so we will need to insert that. And that's going to need a little bit of work in going to all of the base entities and finding all of the names of data members from that. It's not difficult to write that program. It's just a loop that goes through all of them, or a recursive method, however you want to write it, that goes through all of these and collects the names of the members. It's still an important thing to keep in mind is keep your templates as simple as possible. Don't write code right inside here. Call a method instead, like data member name here or JName or whatever, instead of writing something big and complicated inside a template. Templates are difficult to read. It's hard to, because you have to think, it's like writing a program it's an abstraction step away, because you have to think about the program that your code is going to generate. And by experience, that's difficult, and keeping the template simpler here reduces the risk of generating code which is incorrect. If you generate dynamically typed code, there's of course some things that are easier, but it also means that there is of course a risk that at some point your dynamically generated code will fail because there's something that you hadn't thought of. But it's usually significantly easier. And also, often for generated code by construction, we know that it's going to be correct. So in some ways, we don't need the types as much as we do when we write code manually. And that makes it a bit more convenient for us when we are writing generators. So that's it for generators.